Hello everyone, today I want to show you how to create that suspension bridge in Planet Geometry nodes. I was inspired by Arendale's suspension bridge tutorial. Sadly it was made with an early version of Planet Geometry nodes, and at least for me it's always hard to translate these early versions into the versions of 3.0 or higher. So I gave it a try and tried to create my own version of the suspension bridge. So if you want to know how to create that, just watch that video. So let's start with our default cube, activate geometry nodes and create a new geometry node setup and disconnect input from output, and we will start with a quadratic Bezier curve. Let's connect it to the output, and as you can see that will be the base shape of our bridge. Of course we want to bend it in the z-axis in the middle point, so we have to type in -1 at the z-axis. Now we want to have control about the start point and the end point, and to gain that we will need a combine x, y, z node, and we plug that into the start point and the x value into our group input, and now we have control about the start point. Now we want to have the same control for our endpoint, therefore we just copy and paste the combined XYZ node and connect the X with the end. And first of all we need a math node that we set to multiply -1, because we just want to mirror the bridge, and connect that to the endpoint, and now we have perfect control about our start and end point of the bridge. So let's give it some real world measurements, maybe the bridge 5 meters, so that will be 10 meters. That's maybe 4. And now we want control about our middle point, so let's add another combined XYZ node. First of all we have to rename that. The first one we will rename that to bridge length. That's right, no, bridge length. So, and now we are going to connect the Z input with our group input, and we are going to rename that bridge midpoint Z. Let's connect it with the middle point, and now we have control about the quadratic Bezier curve. Now of course we want to have 2 of these quadratic Bezier curves, and in between these 2 curves we want to place our boards, or wood boards there where you can walk off or walk on, and to do that we just copy that quadratic Bezier curve. Now we need also control about the x position or the width of our bridge, and to do that we will connect all the y sockets with our group input, and we will name that bridge width. Terrible word for German. And again with the midpoint and with the endpoint. So now we have control about the y position of our bridge. Let's make it 2 meters and 5 meters so that we can see something. Now you can just copy and paste the whole combine x, y, z nodes And you can also copy that multiply node. And first of all, we are going to create a join geometry node. Like that. At the moment we can see the original Bezier curve. And now we are going to connect the width with our multiply node and connect that one with all of the others y inputs. With that we will achieve that we just make a copy, a mirror copy of that one to the other side. So and now you can connect the first socket with the start, the middle one with the middle, and the last one with the endpoint. And the reason why we can't see something, the second Bezier curve, is because all the values here are set to 0 yet. So we can change that. First of all, we are connecting the length. So that one will be accordingly to the first one, will go right here. And that one, the mirrored x parameter will go into the lower one. Then the midpoint will be exactly the same, like this. And there we have the base model of our bridge. Now two Bezier curves are moving exact the same way, and we can control the bridge, and the midpoint will be the red x-axis. So let's make some frames around it so that we can to keep things organized. Maybe we can call that the left rope, and the other one will be the right rope. That one will be, oh no, let's make an extra frame around it. Hit Ctrl J, by the way, and that one will be the parameter that defines the bridge length, and that one here will be the parameter that defines the bridge width. So it's important that you name all the containers, because we're going to have a bunch of nodes, and if you don't keep things organized, it will be one mess at the end. So I strongly recommend to organize your frames. Now there are two things left to do. We want control about the Z position of our endpoints and the X position of our middle point. So to control that, we connect the Z point of our left rope with that group input. Hit N to open the side menu, and we will rename that start point 1 set position, and we will also connect that with the X with the Z value of the mirrored Bezier curve. So now we should have control about the height of the one side, and of course we want to control the other side too, and therefore we are going to connect the end of our one curve with the group input, and we will rename that start point 2 Z position, and of course we're going to connect that with the endpoint of our other rope, and now we should have control about that position of one side and that position of the other side. Now the only thing we have to control is the X position of the midpoint, because sometimes when you make something like that, the midpoint of your bridge will no longer be exactly in the middle. It will be more something like to the left, and to make that more realistic, we want control about the X position, and to do that we connect the midpoint X position with our group input, and we rename that midpoint X position, and of course we have to connect that with the X position of our another curve, and now we should have control about the X position of two curves. Now we continue, and let's give the lower ropes some thickness. Let's move that a little bit to the right, and we group that, Control J, and we will rename that to lower ropes, because later on we will create some ropes that will be on the height of your hands, just like that. And now we are going to create the some thickness to our ropes, and to do that we will need a curve to mesh node. Where is it? Curve. God fuck it. Curve to mesh node. There it is. And of course we will need some kind of profile, and for that we will need a curve circle node. Plug that right here. And now we fill caps. And now we've got some very thick ropes for our bridge, and we can change that with the radius, maybe something like that. That looks like maybe a little bit too thin for our strong bridge, like that. And of course we want to control that later on. Just copy and paste or duplicate your group input and connect the radius with an empty socket, and rename that to how to name that rope thickness. Now we have also control about the thickness of our ropes in our modifier panel. Now it's time to create some wood boards where you can walk on. First of all, we are going to make a group around that group here, and we will rename that Control J. Control J. We will rename that thickness to lower ropes. And now we are going to make some boards, and to do that we will create a cube that will be the base of our boards. And to see something, create another join geometry node and connect that. Now we have our cube visible in our viewport. Now what we need is another group input. Because we want to make the width and the height, the size automatically adjusted to our bridge, and to do that we have to connect the bridge width with our size of our cube. And first of all we are going to need a combine X, Y, Z node, because we only want to have the Y channel affected. Connect that with our Y channel, and that one with the size. You can see nothing because the other values are set to 0. Make a connection with the X input to the group input, and we will rename that boards width. Now we have control about the width of our boards, and of course we want to control the height of our boards. We will rename that to boards thickness, and now we can control the thickness of our boards. Now you can see that the width of our board does not apply correct to the width of our bridge, and to be exactly, it's the half of our bridge, because at the beginning we mirrored our bridge with -1. So in fact we have to double the size of our boards, and to do that we will need a math node that we set to multiply with 2. And now you can see we have exact the width of our bridge, but because we want our boards a little bit wider than the bridge, because otherwise our ropes can't be connected with our boards, just make it a little bit larger. If you want to, you can connect that parameter with your group input to have later on control with it, but I will leave it for the moment like that. I will make a new group, Control J, and I rename it to boards. Now it's time to arrange the boards along our bridge curve, our bridge ropes, and to do that we will need, just disconnect that. To do that we will need instance on points node. We can delete the join geometry. We don't need that too. And because we don't see anything is because we have to connect the curve to mesh node again with our output. And to do that we need again another join geometry node. Now connect the curve to mesh with our geometry node, and there are our curves again. And now we can connect our boards with our instance on points node, and as you can see it's aligned to our boards, but of course not perfectly, because they are aligned all in the same direction. And now you might think that you can solve that with some normal node or some Euler rotation node, but the Euler rotation node only works if you have a distribute points on faces node. For example, like that, distribute points on faces node. But that node will distribute all the boards randomly on our rope, and we don't want that, so we can't use any normal position or something like that. But to achieve that, we will need a curve to points node. So we will create a curve to points node. Where is it? Curve to points node. Now we can't connect the curve to mesh node with our curve to points node, because we have already created a mesh, and that node needs a curve node. And to do that we have to get one step further and connect our join geometry node with our curve to points node, because at the point where the join geometry node is placed, we have still some curves before it. So now if we connect the instance on points node with our points, they are still positioned in the wrong direction, but now we have a rotation output that we can connect with our rotation from our instance on points node, and that still looks wrong. We can control that with adding a rotation instance node after our instance on points node. We cannot use a simple transform node because with a transform node, the all the instances would be transformed, rotated at once. So, for example, if we would rotate them on the y-axis by 90 degrees, all of the boards would be rotated, and that would not what we want. And with our rotate instance node, every single instance will be rotated. And now we have to rotate them, I think 90 degree on the y-axis and 90 degree on the z-axis. And that looks right. There's only one problem I see. I think I connected the wrong curve. The problem is now we have the double amount of boards because we have the double amount of quadratic Bezier curves. We only have to connect it with one curve. I decided to go with the upper one because that looks nicer in our grid. And now we have only one side of boards. Now rotate instance node, the y axis 90 degree and the z axis 90 degree. Now we have to move our boards into the middle of our bridge. We could do that with some positioning node, maybe transform node or something like that. But the problem is that they are always now, no matter how we transform them, they are always positioned, orientated at the left rope. And I think that would cause some problems if we if you want to bend our bridge like a curve or something like that. So I would like to create another rope just in the middle and orientate our boards in the middle of our bridge. And to do that, we will jump back to the start. And we have to create another node setup. We could use that one too and just create another one just like here in the middle, but that's a mess already. I would prefer to create a new one. So something like that. We can copy our group output. We can copy our combine X, Y, Z nodes. And we need the multiply node. So now let's see how we get them together. First of all, I'm going to connect that with our join geometry node so that we can see something. Here's our new curve. Now we connect the bridge length again with one with the multiply value and with our X input, and that one goes into the start. Now the other one goes, the endpoint goes directly into the X point without getting multiplied with -1. That goes into the end. Now the bridge midpoint Z goes into the midpoint Z, that goes into the middle section. And now we only have to arrange the Z positions of our endpoints. And to do that, I think that one was the upper one. No, just be careful that you plug in the right inputs to the outputs. At my node tree here below, it's just the other one, so you can see it's exactly the height of that, and that will be the height of that one. So I connect these two and these two, and the only thing we have to do that's left to do is the midpoint of our curve. And to connect that, we will connect the midpoint position with that, and now we have a perfect arranged curve in the middle of our bridge. Now we can disconnect that from our join geometry node because we don't want to see it. It will be invisible. Let's make a new group and we will rename that invisible middle rope or something like that. So now let's get back to our boards. And now instead of connecting our left rope with our curve to points node, we will connect our mid curve. And now our boards are perfectly arranged on our bridge and we have control about everything. So now let's get back to our boards. Where are they? There are our boards. And now let's add some random distortion so that they look a little bit old or shabby, whatever you want. To do that, we will need a set position node. And to get some distortion in it, we will also need a subdivision surface node. No, the subdivision surface node will be later on that the sharp edges disappear, and the subdivisions for our noise distortion we will get from the vertices here from our cube node. So something like that. I think we can level it to 2 and crease will be about 2.0, and now we can increase our vertices. We can use 7 or 8 for the X, 4 maybe at the Y, and about 5 at our Z channel. And as you can see, it looks pretty good. You can increase what do we get here? Is that the Y? And as you increase the Y resolution, the better the edges get. Now, of course, we need a Z shade smooth node because that looks pretty ugly here. Z shade smooth node. We will plug that right at the end. And now we got our boards. By the way, you can control the density of your boards with the, where is it? With the curve to points count value. So we will create another group input node. And connect the count with an empty socket. And we will name that boards density. So that looks pretty cool too. Now back to, we can hit Ctrl J, another group. We name that boards, boards density. Now back to our boards, we will create some noise so that they look shabby. And to do that, we need, of course, a noise node. Noise texture, we will need a position node. God damn it. What the position node? There it is. We will need a vector math node, and we will later on need another vector math node. So we are going to connect the position node with the vector math and also the noise texture, the color output with our vector math. That will give us the position of each vertex point of our boards, and will put on the noise texture to it. Because a noise texture is always a displacement, and it gets displaced 0.5 to each direction, we have to subtract that value, because therefore we set the vector math node to subtract, and now type in 0.5, 0.5, 0.5, and now connect that with the upper one, and now the subtract output goes into the position node of the Z position. Now, of course, that's way too much. Just let's see what happens when we don't plug that into the subtract node. You can see our boards are moved away from our bridge, and we don't want that. Now they are again perfectly aligned, and we have to lower our noise texture, and the values 1, 3, roughness we can leave at 0.5 and the distortion to 0, and now we got some pretty even looking distortion. But that doesn't matter at all, because you will never look at a straight angle to the bridge, and we are going to change the random orientation soon too, so you will never see that they have all the same distortion. So let's get back to our instance on points node. Let's make a group, hit Ctrl J, and we are going to rename it Distribution of Boards. And now we are going to add some random value to it, and to do that we are going to add a random value node. And we set this to vector, and we want to use the rotation output that comes from the curve to points node, and we just want to change it slightly, and to do that we need a vector math node, and we now connect the rotation output and the random value with our vector math node. We can leave it at add. Now plug that right here, and you see they're distorted in many directions, and that's why the standard values are 1, 1, 1, and that's too much for us. We will start with 0, 0, 0 and see what all the values do. So now that one will distort or will rotate the boards in the x direction. Maybe we can leave that to 0.1. 2, that 0.15 maybe, and the Y channel we can set to maybe, that's too much, maybe 0.05, and the Z channel we can turn to maybe 0.08, 0.1. Let's see what happens. I think that's enough. Let's see what happens when we increase the density of our boards, and you don't see that they're all distorted the same way. If you would like to distort them all individually, it's a little bit complicated, at least I think. If you have a better solution, please write in the comments. It does not work that you just copy and paste some of the cubes here and then make a joint geometry node, because that will give us the instances of each cube. So you have cubes that are taking the same place. So if you would like to make really different boards, I think you have to make a new group, something like that. And in that group you have to put separate geometry nodes objects, and then you can bring that group with drag and drop into the scene, and then plug it into instance and activate pick instance. And I think then you got really different boards, but I think that's cheated pretty well. So in that case, or for sake of that tutorial, we don't need that. We can make the bridge look even older if we add some random gaps between the boards, and to achieve that we can add another noise texture and a color ramp node. Plug the factor into the factor input and the color output into the selection, and maybe we scale the type in 3 at scale, and now we have control with the color ramp about the missing boards on our bridge, and you can make it look very old and shabby. Now the next thing that we're going to do is to add the hand ropes below and some poles and some curly ropes that will hold the bridge together. But before we add some ropes, we will add some brackets or mounts where the bridge is hanging on, and to do that we will create another curve line. I will place that right under the boards. Oh, I see I did not make a frame around that. That was the board distortion. Back to our brackets, our mounts, a curve line, and we will need a resample curve so that we have some control about the resolution. And we want to give it some kind of radius, set curve radius. We need that to control the spline parameter node, so that we can control the thickness at the bottom and the thickness on the top. We will need a spline parameter. No, spline parameter. Where is it? There it is. And we need, of course, a color ramp to control the spline parameter. Plug the factor into factor, and the color ramp goes into the radius, so we can see nothing at all. Let's create a join geometry node and plug the set curve radius into the join geometry node, and there it is, our single curve line. Now we want to give the curve line a thickness, therefore we need a curve to mesh node, and I decided to use a star node. You can use whatever you want. You can use some circle line. You can use what else do we got here? Where is it? Curve node, curve primitives. You can use some of these here, but I decided to use a star node because I can change the shape very quickly. So plug in the curve into the profile curve, and now you see we get something like a star, and we fill the gaps. Now the radius is much too high, maybe something like that, and the outer radius something like 0.8. And now we have to make it a little bit higher, something like that. And as you can see, it's very like a needle on the top. We don't want that. just invert the color ramp and make the black color into something white. And to make it look like some ancient stone mount, we can use 4 points, maybe something like that, or 3. That's up to you. And now we need an instance on points node. We will make that a little bit more beautiful soon. So first of all, instance on points node, because I want to see if it works on the endpoints of our rope. So that's our instance on points node. No, that's our instance, and we have to give it to say where it should be placed, and therefore we will go with our quadratic Bezier curve from the beginning, and we drag a long line to the instance node of our mount, and there are our mounts, exactly the same number as our boards. And to define that we only want to have at the endpoint, at the start point, our mounts, we have to add an endpoint selection node that we can plug into our selection. And now we got only one at the beginning and one at the end. And because we want them two on the other side, just copy that instance on points node, make that selection of the endpoints here too, and copy that curve to mesh node into the instance. But now we need the other curve. That was the lower one we just used, so we use now the upper one and connect it with our instance on points. And of course we need a join geometry node. And now we got our mounts for our bridge, and they should move along our bridge. Yes, works everything fine. So now we can make our boards a little bit more like some stone or whatever. And to achieve that, we will add a subdivide mesh node. Subdivide mesh node, and we will plug that right after our join geometry node, so we have to do it only once. So we can add some geometry now, and we will need a subdivision surface. Well, maybe something like that. You can play with the values until you got something you like. And what we can do now is add another group input, and we make some control about our radius of our mounts. And to do that, we will first of all connect the inner radius. We will 0.5 maybe, and we want to have control about the outer radius too, but we only want to have one control in our modifier panel, and therefore we will add a math node, which we set to add, and we only add a small amount, maybe 0.2, and we plug that into the outer radius, and now we have control about our poles with only one parameter. Maybe we can add the points node to control the shape. Let's add some nodes. Inner radius, we will name that mount radius, and that will be our mount shape. So now, first of all, let's make a big frame around our mounts. Hit Ctrl J, arrange it a little bit, something like that, and we will name that mount distribution. So there's one problem. The endpoint of our mount is exact on the same point as the end and start point of our boards. And to change that, we will go right at the point where we add our curve to points node. That's the point where we take our invisible middle rope and changed it from quadratic Bezier into curve points. No, change is not the right word. We add some points to the curve, and we will plug between the quadratic Bezier curve and our curve to points node. We will add a delete geometry node, and we will add an endpoint selection node. And as we can see, we now have control about the start and the end point of our boards. I think that should be enough so that they don't intersect. Make another frame and name it delete first boards. So now, before we can add our ropes where you can put your hand on, we have to jump back to our mount distribution, our mounts, and just at the beginning we have to define the height of our mounts. We will add a group input, and we have to add a combine XYZ node. Combine XYZ node, and we will plug the Z value into an empty slot, and we will name that mount height. Plug that into the endpoint, and now we have control about the height of our bridge. Yes, something like that. And now we can arrange our hand ropes accordingly to the height of our mount heights. So we don't have to use two values, the height of our hand ropes and the height of our mounts. So we can only use one height to change two different things. Now it's time to create our hand ropes. First of all, I'm going to make our bridge complete, something like that. And now we have to go to the start where we created our ropes, and now we need to add again a quadratic Bezier. Like we put it here. Here is free space, and now we can just use the inputs that we used for our right one, for our right rope. We can just plug that into our hand rope, and we will need a join geometry node so that we can see that everything works out fine. We can plug that into that geometry node. But we can see nothing because now it's exactly aligned on the that rope. And now we also want to give it some thickness. Therefore we add a curve to mesh node. And the profile will be a curve circle node with fill caps. And to have full control about the rope thickness, we can add a group input, and we already have an input for our thickness. That's this one, radius. Now it's exactly like that rope, and now we have to add a set position node like here, and now we can control the height with a combine x, y, z node. And now we can we need another math node, because we want to control the height that is not exactly the height of our mounts, and we subtract some height, and we will use the mount height, and we will plug that into our z value, and the combining x, y, z goes into the offset, and there it is, our hand rope. So now that value here, that's how much we subtract from our pole height. So if it's set to 0, the hand rope is exactly the same height as our mounts, and the more we subtract, the lower the hand rope gets. So we can use that as another value. Hit N to open the side panel, and we will change, we'll name that hand rope Z position, or hand rope height. Now we make a frame around that, and we will name that hand rope 1. Now we can just copy that whole thing, hit Shift D to copy everything, and now we just can use our right rope. What was it? It was the first parameter, so that one goes into the start point. The middle one goes into the midpoint, and of course the last one goes into the last one of our quadratic Bezier of the hand rope 2. Where it is there, hand rope 2, and of course we have to connect it with our join geometry node, and there we have our second hand rope. Let's check if everything is working. That looks good. That looks good too. The midpoint changes perfectly. Let's change the mount height, and our ropes go automatically with our mounts, and we can change the height of our hand ropes. So next thing we are going to add is some vertical ropes that will hold the bridge together, and to do that we will create another quadratic Bezier, and I think we will place our vertical ropes below our mount distribution frame. There is some space left. Maybe you organize your frames a little bit better than I do in that tutorial. Now to create the ropes we will need another quadratic Bezier. we will need a curve to mesh node. We will need a curve circle node. We fill the caps and we connect that one with the curve to mesh. We will create a join geometry node. Join geometry node, maybe here, and connect that with that one so that we can see something. So here's our quadratic Bezier that we just created. And of course we have to give it the right shape. So now we open another group input. And now we have to give the quadratic Bezier exactly the height between our lower ropes and our hand ropes. First of all, we are going to add, we make out that curve line, and now we have to define the endpoint of that line. And the endpoint will be the height of our mounts subtracted with the height of our lower ropes. So to do that, we need a combine XYZ node. Another combine XYZ node because we only need the Z values. And now we subtract from the mount height, we subtract the hand rope height. And of course we need a vector math node set to subtract. Connect everything, and that one will go into the AND connection, and we already got something that is has exactly the height of our bridge. It's a little bit ugly at the moment now. We can connect the radius of our rope thickness. Now it's a perfect rope like the others. And now we need instance on points node. No. Instance on points node. There it is. And the instance will be once again our where it is, our curve to points node that we use for everything. There it is, our quadratic Bezier. My god, where is it? Curve to points. There it is. It is on our board density frame. Here it is, curve to points node. I think we have to go out after we deleted the geometry. No, we will first try the normal output curve to points node and go all the way down to our that one. Sorry, we have to connect that with our instance, not with the points. And we got some vertical ropes, but they are positioned right in the middle, where is our invisible bridge rope. But that is important because we use that middle bridge rope for our instances, and it's important that we have exactly the same vertical ropes as the amount of boards we have. If we would use one of the other curves, the amount would be different between, so we have a different amount of boards and vertical ropes. So to change that, to align that, the vertical ropes to the horizontal ropes, we will use another group input. We will use a transform node. We will need a combine XYZ node. and we will need a math node that we first set to add. So now we want to add our the width of our bridge, and to do that, where is it? Bridge width. We want to add the bridge width to 0. Connect that with our, wait a minute, what is it? It is our y-axis, and that one we connect with our translation, and we got perfectly aligned vertical ropes. Now we have to copy that whole node tree. Maybe we set a frame first, and we will name that range vertical ropes 1. No, that's ropes. So now we can copy that and just use it the instance again, and we will also need the points input. I now hit shift and right mouse, and I make that point, so now I can drag that to that instance on points node without going the whole way back again. Now connect the transform node with the join geometry node, and we change the math node from add to subtract. So now it is positioned directly on the other side, and now we have a beautiful bridge with vertical ropes. And now there's only 2 things left that we have to do. We have to add some knots, some rings where our bridge is held, and we also have to add some curly ropes, but that's up to you. You can leave that if you want, but for those of you who want the full tutorial, the full length tutorial, you can you just keep on watching. So first of all, we are going to add our rings, our knots to the connection between the vertical and the horizontal ropes. Let's search for a free place. Maybe we can rename that to make that into a frame, and we will name that vertical ropes. Oh, there. Now I think we use that edge here, that little corner, and we will create a curve circle. And maybe first of all, we to see what we are doing here, we connect it with one of our instances so that we have full control. We need a set position node. Plug that right here, and now to see something, we will use our vertical rope. I think it's pronounced vertical rope input. And to do that, we will create a join geometry node right before our instance on points node. Join geometry node like this, and another one. And now we are going to connect one of our circle rings that will be our knot with these two. And as you can see, we get some rings at exactly at the same position as our ropes and our boards. And now the only thing we have to do now, that looks pretty ugly. The only thing we have to do now is to arrange the rings in the right angle and give them some thickness. So first of all, we are going to make a frame. I'll call that knots. So now let's make some knots. First of all, we are going to make them much smaller, maybe 0.05. So they are now hidden inside the boards. Now we need a transform node. And we will set the X angle and the Z angle to 90 degrees. And it should now, no, 90. And now you can already see they are arranged at the right angle. Now we have to give them some thickness. Therefore we will use a curve to mesh node. And with a curve circle profile, plug that into profile, fill the caps, and radius is much too big, maybe 0.02. Now that looks fine. Now we have to get them to the hand rope height, and to do that we use that position node that we already put in here, and we will need another group input. We will need we will need god damn it. What the combine XYZ. There it is. Oh, finally. Now we need another math node. And we now have to subtract the mount height with the rope height again, like we did with the ropes. So now where is the mount height? Like that. And where is our rope height? Like this. And that goes into the Z value, and that goes into the offset of our Z position node. And we got some beautiful, cool rings around that. Maybe we can connect the radius of our curve circle with the rope thickness. That should maybe give us exactly the right position, the right radius, and maybe we add some math node, which we set to add, and only add a small amount, something like that, and that makes sure that we always have the rings around our ropes, no matter how thick we make our ropes. So we have that, and now the only thing that is missing right now is these curly ropes that you saw at the beginning. And to create these curly ropes, we first have to search a free corner, maybe above our hand rope frames. And we will need 3 quadratic Bezier curves. No, quadratic Bezier, and we need 3 of them. And we gave them exactly the positions that we defined for the right and the left rope. So we can first use our left rope and connect the start with our start. We connect the midpoint with our midpoint and the endpoint with our endpoint. So of course we can't see nothing because it's exactly aligned on our ropes. Now we need 3 of them because we want 3 different curled ropes. Now I press Shift and right click to create these dots here, and now I can connect them again with the 2 other Bezier curves, and that one was the start one, and that was the middle one. So now we have 3 quadratic Bezier curves positioned exactly on the rope, and we can see nothing because we did not join them into one geometry. So plug that everything into a join geometry node, and we can plug that, maybe another one to keep things organized, and that one into another join geometry node. And again, we can see nothing. It's all inside that rope. Now we want to make them curly, and to do that we will need a set position node, and now add a noise texture. We will need a position node. We will need a vector math node. We can connect the position with the vector math node. The position will give us later on the position of each point we have to distort. We have to, where the noise texture is distorting our rope, and we connect the color with our vector input, with our vector math node. And again, we will need a subtract node, as we did before, because our noise texture is some kind of distortion. It distorts our rope, and we have to bring them back by 0.5, 0.5, 0.5, 0.5, and that one will go into our position input of the set position. Let's add some thickness to our curve so that we can see something. Again, we will need a curve to mesh node. We will need a curve circle node. The curve circle we plug into our profile. We fill the caps. We will need another group input because we want to have the same radius for our distorted ropes, and we will use the, where is it, rope thickness as radius. And as you can see, we already got one rope. To get more ropes, we have to set different resolutions. So one of them maybe 29 and the other one 23. So we have now 3 different ropes. Now we can come back to our noise texture and set some other settings. For example, 0.02 and the detail about 8, the roughness 0.9, and the distortion we can crank it a little bit up, so something like that. And we will add between our noise texture and our vector add node, we will add an RGB curves node. And with that we can make the distortion a little bit higher, and you can control now with the factor maybe to 3. We can control the intensity of our distortion like that. Maybe 3 is too high. Maybe we can the 2. Now that looks a little bit shitty, more like metal pipes. Let's go to the end after the curve to mesh, and let's add a subdivision surface node. Maybe we could put it to 3, and now that looks like some curly ropes. There is still one thing that is not good. As you can see, when we change our distortion, the ending of our ropes keeps dancing around, and to avoid that, we will need again an endpoint selection node that we can plug into our selection. Now everything is selected. Now we need a color ramp node that we plug right in between, and let's change that, invert that. So what that node does is it only affects the end point and the start point, and when we now distort our ropes, the endpoint and the start point keeps at the right position, and only the points in between are changing. So now we got one of our ropes. You can also change the distortion by changing the resolution of your rope. So now we got that for one side. Of course we need that for our other side. No, that's wrong. We first do it with the upper rope, and the lower rope will be a different node tree. So maybe first of all we hit Ctrl J and name that distorted rope left side. Now we will make the same rope on the upper rope, and to do that let me have a quick look at my notes. We will set another set position node. Where is it? Set position node. In fact, we will add 2 set position nodes. So the first one, we will need to set our ropes a little bit higher, because they are now most of them are under our boards. So maybe we can use that to arrange them a little bit better, something like that. And the lower one will be to move the ropes up to the hand rope. And to do that we need a math node again, and we will need combine X, Y, Z node, and again we will subtract the mount height, and we will subtract from that the hand rope height, and that goes into our Z position, and that value goes right into our second Z position node in the offset. And what this the effect of that is that we have 2 ropes. The first one is on the lower one, and the second one is on the upper one. And we have to set this, of course, to subtract and not to add. And now we got some ropes on our hand rope. Now the next part is pretty easy. Just copy and paste that whole block. Search a right place, maybe behind that. And what you have to do now is just, I will delete these knots. What we have to do now is take the right rope, before we connected it with the left rope. Now we take the right rope and connect that one with our start, the midpoint with our midpoint, and the endpoint with one of our endpoints. Again, hit Shift right mouse and then connect all the others. Start, middle, and endpoint. And now connect that again with the join geometry node. And voila, we've got the curled ropes on both sides and on the lower one and the upper one. And the only thing we have to do now is to add some material. For the material, I used my Blender Kit add-on. I will show you that. Here's the Blender Kit panel. You only have to type in wood at the material selection, and then you get a lot of wood material. You can always choose between procedural and texture base. I did not know which one I use, but you can drag and drop that right into your scene. Be aware that you cannot put that material on the whole geometry node setup. You have to create a separate plane, and then you can drag and drop your material right onto that plane. There it is, and now you can use it as material. Be aware of that you sometimes have to change the texture coordinate input from UV map to generated or object so that it works. So in my case, I can show you what I have used for material. Where it is, let's go to our boards at that place here. Use a set material node, and I named it Procedural wood. There it is, my wood. And for the ropes, I think I used, where can I place my ropes? Set material. I think I used procedural rope. There it is, and there, and so on. You know where that leads. You know where that all leads to. And we've got some pretty cool looking suspension bridge with many possible modifications. I hope the tutorial was not too long and you learned something. Hope I see you next time. Bye.